Today we will be covering these two topics that are in magnetic field due to current carrying conductor. So our first topic is magnetic field and field lines. As we all know, a magnet has two poles that are north pole and south pole. Like poles repel each other is north pole or south pole and south pole. Whereas unlike poles attract each other like north pole and south pole. Magnetic field. This is the region around a magnet in which the force of attraction or repulsion produced by a magnet which can be detected. That is, these all are the magnetic field lines. These all are the magnetic field lines. Properties of magnetic field lines. Outside the magnet, that is this bar magnet, the magnetic field lines are from north to the southward direction, like these. You can say these field lines. These travel from the north to the south pole. Inside the magnetic net, field lines are traveling from south pole to the north pole. The strength of a magnet or magnetic field given by how close these field lines are, that is, the magnetic field lines around here are very much closer to the magnet. Hence, here the magnetic field intensity is more. In this particular region, magnetic field lines are far away from this magnet. We can say here the intensity of magnetic field force will be less as compared to this region. Our third point is no two magnetic field lines ever intersect each other. That is, suppose we have a magnetic field line like this. According to this point, there will be no field line that will be intersecting this field line like this. So we will say this scenario will never occur. Our next topic for today is magnetic field lines around a current carrying conductor. Current carrying conductor creates a magnetic field around it, as shown here. Suppose this wire carrying a current in this direction. Now these circles show the concentric circles which are showing the direction of magnetic field lines given by the arrows. The strength of magnetic field created depends on the current to the conductor. Suppose we increase the value of current through this conductor, that will also increase the magnetic field lines that are concentric about this current carrying conductor. The magnetic field produced by a current carrying straight wire depends inversely to the distance from it. If we move far away from this current carrying conductor, suppose from point this, some point this, then the magnetic field intensity will decrease. If we go from point this to point this, that is, we are coming near to the current carrying conductor. In this case, the magnetic field intensity will increase. The direction of magnetic field lines around a current carrying conductor is given by Maxwell's right hand grip rule, or we can say it the right-handed corkscrew rule. That will also give the same result. Imagine that you are holding a current carrying conductor in your hand such that the thumb points towards the direction of current as shown in this figure. Here, if you hold this particular wire in your right hand, then the curl of the fingers will show the direction of magnetic field. The thumb should be in the direction of the current. Then this curl, this particular direction, will show the direction of the magnetic field lines. Here, these all circles will be showing the direction of magnetic field. Here we have a question, example 13.1. The question states that a current through a horizontal power line goes in east to west direction. Let's draw it. When it asks what is the direction of magnetic field at a point directly below it and slightly above it. Other directions are what? The current is in east to west direction here. So we apply Fleming's right hand rule. Draw a circle around the state current conductor. Here, if we apply Fleming's right hand rule, our curl will be this direction here. So below a point, the direction of magnetic field from north to south, and above a point, above it, this point, the direction of magnetic field is from south to north direction. This was in this video. We will be covering next topics in another video.